So here we are going to look at the intersection of this cone and this plane, and we want to parameterize the intersection of that curve, and we will do it in two different ways and then verify with MATLAB that we have the same answer. All right. So one way here is a way that looks easy is that let's just take z equals t as one of your class answers indicated. Then y equals how much? T minus 6, and that will tell us, what will that tell us? That from this equation of the cone, I have t here, and this would be what, t minus 6 squared, right? Okay, so t minus 6, that quantity is squared. And if I square both the sides, what will I get? I'll get t square, okay, equals x square plus t minus 6 square. What we are trying to do is that we are trying to get value of x. All right, okay, and that is going to give us, what is that going to give us? Is that this equals t square, okay, and which means we'll just go ahead and FOIL t minus 6 square. So what we get is this here, t square minus 12t plus 36. Now this t square and that t square will cancel, right? And x square becomes 12t minus 36, and then x will have to be square root of, or actually plus or minus a square root of, all right, how much? 12t minus 36, and we have to have the value of t to be greater than or equal to 3. 12 times 3 is 36. In order for this to make sense, so we will have to have like two branches of the curves here. On the other hand, say we decided to, this is just another way, we have already parameterized it in that way. So you can see that the value of z can be written in two forms. So here we can write x and y in terms of each other, hopefully by solving this equation, by equating to, or rather by process of elimination of z. So we get 6 plus y squared, right? Okay, and then what happens is we get x square plus y square equals, just FOIL the right hand side, what you would get is y square plus 12y plus 36. Am I right? Yes, looks right. Okay, so y squares cancel, and then what I am going to do is that I'm going to write y in terms of x square and see where it takes us. Okay, so we have more space here. So this is what we got, which means that let me just decrease the font size. We may be able to get by with lower font size. So y becomes how much then? 1 over 12, okay, x square minus 36, right? Okay, and if I do this, that is after this I have to find z. All right, so how much is z? Z is 6 plus y. So I'll go ahead and just substitute this value. So what we did was that we found the values of y and z in terms of x, and then that will help me do what? That will help me take up sets x equal to the parameter and avoid the square roots, right? So we go here, and what we have is we can take 12 as common denominator, right? Okay, right. So here we have 72 plus x square minus 36, right? Okay. Yeah, I don't know who I'm asking because I am the only one talking and listening here. Okay, so we got this, and then this changes to 1 over 12, and then what, x square plus 36, right? So here if I took x equals x equals t, then y is t square minus 36, right? And z is 1 over 12 t square plus 36, right? Okay, so these are two ways we have done this, and I didn't think that will take me that long to do this. So what we are going to do is, now we are going to go to MATLAB, and we are going to use now what is called live script to type the command so that we can handle them more easily later on. All right. So now we have MATLAB, and what I would do is that I shall ask for a new live script. Okay, so here is a new live script. It gave it to me in a different what do you say, in a different window, and I'm trying to bring it over to you guys here, and I hope it lets me do that. Yes, so we have it here. Okay, so what we got is, okay, that so here is a live editor. So what we are going to do first is that let me bring that back, that we are going to graph these two first. Okay, so what we are going, we are simply graphing surfaces there, right? So I'm going to write sims x, y, z. Okay, and then I'm going to define my function of x, y, and z. The first one is the square root of x square plus y square. Remember, that's what I'm taking, fxyz. I'm so sorry, I should have written it fxy. Just trying to hurry it. Okay, so anyways, we are right here. Okay, and then how do we graph this? We just say fsurf. Okay, and then we will say f, and let's just graph it in our typical window. Okay, all right, so here we have graphed it. The graph didn't show up, so I can do this. I'm doing this in Windows, that is pressing Control Enter. So here it comes up and it should graph, hopefully. Yes, it did. Okay, so here is a graph of this cone. I'll say hold on. All right, now I'm going to define my gxy, z as a function of x and y, as the other function. Who was that? 6 plus y, right? And then I'm going to say this here. So I'm saying fsurf, and here instead of f I have g, sorry, and I will do Control Enter again. So let's see what it does. It's taking a little longer. All right, so here we go. So we have do we have the point, the curve of intersection visible? Yes, we do. All right, so now what I'm going to do is, let's hold these graphs on again, and an advantage in this live editor is this, that if we make mistake, we can just go back and edit. All right, so what I'm going to do is that I'm going to graph the curves, and I'm forgetting it so fast. Who were the curves? Okay, the first part was this. square root of 12t minus 36. We'll take positive one first, and if we do that, then y is t minus 6 and z is t. So remember, we plot our curve by using fplot3, and what we have here is 12 times t minus 36 is the first component, right? And I forgot the second one so fast. T minus 6 is the second component, right? And t is the third component. And then we know we have to have more than 3. So let's just stick to 3, 7. Okay. And I'll take like a big line width, because thick line width I meant. Okay, and I would just go ahead and specify the color here as well, and I saw that it takes only in like hexadecimals. So for hexadecimal, see, it says hexadecimal color coding. I just got a couple memorized. One of them is black, the other one is white. So let me just put black here. All right, help me God. Okay, let's see. Oh no, I had to do this. Okay, now again, help me God. I hope that I didn't make any typing mistake. It's taking forever again. And let's see what it brings us here. Okay, so here. So it brings us half that curve, right? And what we can do then is that we can see the other half. All right, and we are doing the same thing that we have done many times. Many of you may have just like turned me off, which is okay. So this time I'm taking the other side, and I'll keep the color as black. Okay, all right. So control enter, and the graph will show up. So, and then we will plot the other parameterization. Okay, it's taking a little longer. Okay, all right. So here it is. Okay, so let's see. Yes, so the graph is here. We can see it's going through the intersection. All right, okay, and then we will ask it to hold on again. Okay, so hold on. And now we would do what? We would, other one, I really forgot what that was. Okay, 1 over, I can remember t square minus 36 over 12, then plus 36 over 12. So we will go fplot3, okay, and then t comma 1 over 12 times t square minus 36, right? Yeah, I hope that you remember that correct. Yes, that's what y is. And then for the next component, what we have is that we have plus 36. I'll keep the line width as 4. And I told you that I'm just growing into this MATLAB 2020. I was using MuPad, which they took away. And I may do this. Let's keep the, then that was 3, 7. Did we give it any interval? No. So here we don't have to restrict it within, like, for greater than or equal to 3. So let's keep it like from, say, -3 to 3. So I just took it up. Okay, and well, let's just make it like, say, white. That's another one that I remember. Otherwise we can always look these guys up, then control enter. All right, let's see what it gives us. Okay, and for some reason I could not find a word that I could type for color. If any of you do, let me know. And I think, yeah, it did it here. Okay. All right, so the graph is not, it's not going very well. This may have to do something with that, or whatever. Okay, so I'll let you play with this. Okay, and I apologize for saying whatever here. Okay, thank you.